Chapter 2, Section 6, Question 0. There is no question 0, but I thought this was important, partially because this question right here is a lot of the reason I am a math teacher. Long ago and far away, I had a teacher who put this on a test, and I did not know how to do it. And I was in Algebra 1, and I didn't know how to do it, and I thought, gosh, those parentheses, he drew them really straight. That's odd. So I thought it was -9. And he marked it wrong. And I said, oh, maybe he just forgot to put the squared up there, so I made it 81. And he marked it wrong. And it took me 2 years to find out how to do this, because I walked up to the teacher, was ignoring our class, and grading papers at the front of the room. I said, excuse me, sir, how do you do this? And he said, go ask your friends. And in 4 words, I learned that I should never ask him a question. And so I asked my students, how do you do this? And they said, oh, to find this, you just look at the distance from 0. -9 is 9 spaces from 0. In 3 words, we can tell how to do this. Other students said, oh, you can also just make it positive. Make it positive in 3 words, you can tell me how to do that problem. So yay. Folks, in the event that I ever ignore you like that, please tell me, because I never want to be a teacher like that. All right, so the absolute value of -9 is +9. How far is 9 away from 0? It is 9 spaces away from 0. Groups first. How far is -3 away from 0? It is 3 spaces away from 0, and this negative just comes down. How far is 17 from 0? It is 17 spaces from 0. And it took me 2 years to figure out how to do that problem. Because if you ever take a look in a textbook, it's usually only 1 sentence, and I missed that. But I know now, and I can teach you that. Chapter 2, Section 6, Questions 1 and 2. So to solve an absolute value equation, we need to isolate the absolute value. We're going to be doing this in Chapter 2. We're also still going to be doing it in Chapters 6, 7, and 8. We're going to isolate this group. So to isolate it, we need to move the 3 to the other side. You don't have to cross it out. Now, consider, based on the last slide, -8 would equal 8, but also 8 would equal 8. So, this inside could be negative. Or the inside could be positive. Many students get this wrong because they know that the absolute value makes it positive, so they put a plus here. Don't do that, because order of operations says you have to do the inside of the group first to get this before you can make it positive. So this negative here, we have to make the entire thing negative. This would be -8 equals 8. This would be +8 equals 8. Now, most people do not do this step. Instead, what they do is they divide both sides by -1, and they start off with 2x minus 3 equals -8, and 2x minus 3 equals +8. So what it looks like is that one of these you leave it alone, and one of them you change the sign on the right-hand side, which is perfectly fine. Most people do not have this up here. I have this T-chart here because I want to make sure that you're working down the page, not across the page. That is important when you get to college. It also means that I can add 3 to both sides here and add 3 to both sides here, and I can kind of solve them simultaneously if that makes sense to you. Notice that here, because that's a -8 and that's a +8, the answers are going to come out differently. And we're dividing both sides by 2, dividing both sides by 2. We get x equals -5/2, and x equals 11/2. I am perfectly fine with these answers. If it makes you feel better to make them into decimals, as long as they're not rounded decimals, that's fine. And then also, at one point in time, the college classes asked for the answer to be written as a set, in which case, remember, sets have the squiggly braces. And we have negative 5 over 2, writing it in order from least to greatest. But we don't need this yet, so we don't need that yet. Big question, will all equations have 2 answers? Here I got 2 answers. Is there ever a time when you will not get 2 answers? You can pause this if you'd like to think about it some more. But if I have 2x minus 3 equals negative 8, can an absolute value equal a negative number? Remember, it's the distance from 0. The distance, no matter how short I am, I have a positive height, no matter how far it is away from 0, it can't have a negative distance. This would be a no solution. But if you had the absolute value of 2x minus 3 equals 0, you can't have a positive 0 and a negative 0. So therefore, this would only have one solution. So not all equations will have 2 answers. These are some very special cases where you would not have 2 answers. But in general, we'll have 2 answers. Also note that we have the negative on the left and the positive on the right. One of our college professors that is very near and dear to his heart. So negative on the left, positive on the right, if you want to prepare better for your college class. Chapter 2, Section 6, Question 3. Inequalities. This is where it's at. We have inequalities. Now, if you remember, we had that t from when we had the equations. So we're going to have the negative version of 3x minus 8 is less than 8, and the positive version of 3x minus 8 is less than 8. We're going to divide both sides by negative 1. Remember, you do not have to write this step, but this is to explain why it looks the way it does. Because most teachers teach you to write it to look almost exactly the same, but here you'll change the 2 things on the outside. Remember, if we divide by a negative, we have to flip that inequality. And here, you would leave it alone. But now that we have this, remember, negative on the left, positive on the right, we could add 8 to both sides on this equation, or inequality, and add 8 to both sides on this one. So the steps should be the same. The answers are going to become different, though. This will be 0, and this will be 16. And then we'll divide everyone by 3, because the work part of this is the same. Now, a lot of students get confused on this because they said this is a no solution. But remember, you can't divide by 0, but a 0 on the top. A 0 on the top is good and will give you 0. A 0 on the bottom is bad and will give you undefined. This is 0 on the top. It is okay and will give you 0. And here we can use 16 over 3. We have to number line this. And so we have 0 and 16 over 3. It says it is, we're thinking about the 2 little pieces, it is greater than but not equal to 0. Notice the really long arrows, it is less than but not equal to 16 over 3. And we have to look at where this is going to be true. This is going to be an AND case. And it would be a good idea to start writing AND there, because we want to look for where they are both true, and it is here. And we have 0 and 16 over 3. Both of them are not equal, so both of them are parentheses. Some people think this looks like an ordered pair, and it does. But because it is an interval notation, this is our interval notation. Now I have a way of remembering this. This problem here is a less than. If you have an absolute value and less than is smaller. So it just goes on the inside. Our next problem will be greater than. Now this is question 3 here, but it could be 3 or 4. So less than is going to be just this little bar on the inside, and I'll make that darker so everyone can see it. So that is our less than problem. If it was less than or equal to, we would put little dots that are shaded in there. Chapter 2, Section 6, Question 4. Now this question 4 could be either question 3 or question 4. You'll find that they kind of move back and forth. We have already isolated our absolute value. Thank goodness, how wonderful. And we can have the negative version of the 4x minus 5 is greater than or equal to 7, or we can have the positive version of 4x minus 5 is greater than or equal to 7. We divide both sides by -1. Notice that I divided by -1, not just a negative. Some people have done that, and that is incorrect. The negatives cancel, and you get 4x minus 5 dividing by a negative. We'll flip this inequality around, and this one is just normal. And then we will add 5 to both sides on this one, and we will add 5 to both sides on this one. All the work steps should be the same. The answers will be different. Reducing the fraction, if you don't reduce the fraction, you're going to lose points. You should know to reduce the fraction. Now, we're going to number line. There's only two important numbers, the -1/2 and the 3. We're thinking about this, and it says from the -1/2 less than, and from the 3 greater than. Hey, this is an or problem, this piece or that piece. I strongly recommend writing the or there. So, here we have two pieces which will be put together with a union. The left is -infinity. Infinities always get parentheses. The right is -1/2. Solid dot, equal sign, connect it. U for union in the middle. Notice, this does not go back down. It's not a lowercase u, it's really an uppercase u. And then 3 to infinity, and equal sign there as well. These should match. Not always, just because they're based off of an absolute value where these both have bars or both have no bars. So that is our answer here. Absolute value greater than, bigger, going on the outside. Absolute value less than, going on the inside. All right. Please make sure that you work down the page. You're solving it. Strongly recommend the or, number line, and writing our inequality in interval notation. Chapter 2, Section 6, Question 5. Now I'll tell you that sometimes I don't have room for this. I believe on the test, question 5 gets moved up with questions 1 and 2 just to have enough room. So here, I have an absolute value equal to another absolute value. So I could have a +8 equals a +8 inside of absolute values. I could have a -8 and a +8. I could have a +8 and a -8. Or I could have a -8 and a -8. But if they're both negative or both positive, that's really the same problem. If I have the one on the left negative or the one on the right negative, that's really just the same problem. So we're going to do something similar to before. And we're going to have 4x minus 5 equals 2x plus 9. And I'm going to make one of the sides negative. Normally, we make the right-hand side negative, and then 4x minus 5 equals 2x plus 9. Here, we would distribute. So normally, instead of writing this, we just change all the things on the right-hand side, and here we don't change anything. We want to get the x's on the left-hand side, or we want to isolate the x's. This one is going to be different. I'm going to add 2x on both sides and also add 5 on both sides. If you want to make that into 2 steps, that is fine. That gives you 6x equals -4. But I don't want to add 2x on both sides here. That's a positive 2x. I have to subtract 2x on both sides. So this is why this is a question 5. This is definitely harder than the others, and eventually we're going to get to problems where you're just going to have to check the answers because they're going to get just that icky. Ooh, I see. Reducing a fraction. That's going to be negative 2/3. And, ooh, that divides nicely. I will get 7. This is a perfectly fine answer for this question.